Hi, how are we feeling today? Sleepy. Like two of you are like, yes. It's like 200 people. Anyway, good to be here. My name is Tejas. That's pronounced like advantageous. Tejas, whether or not it's true, we'll find out. You know, I feel nervous standing up here. All of you people judging me for existing. My palms are sweaty, my knees weak, arms are heavy. There's vomit on my sweater already. Mom's spaghetti. I'm nervous, but on the surface, I look calm and ready. Anyway, whatever. Feel like we should have. Cool. I feel like we should have. There's a clock that's counting down, and I'm ignoring it. I feel like we should have some fun to kind of start the day. You know, keynote. Keynote's supposed to be vibes, right? And maybe a little bit of technical content. But let's just. Oh shit, the counter started. Okay. I wish you didn't start that. Anyway, moving on. Pleasure to be here. Not BEJS, React Brussels. Give yourself some love. Amazing. See, that's what I'm talking about. Awesome. I have one request for me and the other speakers who will follow today. Listen, I struggle to stay hydrated. I don't drink enough water, personally, because I feel like water is boring. I drink a lot of Diet Coke. But every time you see me or a speaker take a drink of water, I want you to celebrate that, okay? Because then we'll do it more. It's NLP. It's like programming, okay? Let's try that now. Thanks. Again, there's one more. Anyway, good. Remind your speakers to drink water, and more importantly, just celebrate them, because it's not easy to travel and then come do all this. And so, if the more speaker support, the better. All right. Nice intro. Let's move on. I'm here. I work at a company called Zeta. That beautiful 3D butterfly is where I work. We actually live inside the butterfly and write code. And what we do is we create a database that's like fun and hopefully pleasurable to use for web and front-end and React developers. But that's not what we're here to talk about today. Today we're here to talk about handling data at scale for React developers. An alternate title, if you will, to the talk is Let's Understand Suspense for Data Fetching. How many of you have heard of Suspense in React? Yes. How many of you use Suspense daily in work? Okay, now, like all the hands went down. He's kind of wait. I don't know. Yeah, so that's what we're here to understand today. Before we get into it, I want to draw for you a diagram, okay, about what the backend is and why it's important that the front end scales accordingly. If I ask you to think about in your mental picturing abilities, like what a backend looks like, can you do that? What do you see? So this is what I want to just draw this so we're all on the same page here. I'm going to use a tool called Excalibur. Oh, that's not very promising, is it? I'm going to use, if you're on the public Wi-Fi, maybe get off. We'll see. I have a mobile hotspot. So draw for me the backend. So a lot of engineers I talk to will draw like, you have some type of UI that then talks to some type of API, right? What's happening? That talks to some type of API like this. And at the end, we'll talk to some type of data layer or a database. Or let's just call it a database for fun. And so now, what you can do is you'll connect them, right? But at some point, you need to scale things. Like your infrastructure will start to get maybe a little bit overwhelmed. And so what happens is you distribute your API. Now you've got multiple API servers and everything's load balanced. You can at least. But then your database is like not going to be able to meet the needs of your users. So you need to scale your database. How do you do this? There's multiple ways, but the easiest way if it's a relational database is probably to just scale it vertically. And that means, let's add some RAM, let's add some disk space, let's make things faster and more capable. And you end up building these beefy supercomputers. It's expensive, though, because it costs money, like electricity. It costs a lot of resources. You have to pay people to it's just complicated. And then you're like, okay, we've maxed out the machines. Now what? So then what's your next step? You scale horizontally with some type of primary replica setup. Okay, that's cool. And this is as your company is growing, right? Data at scale with Suspense for data fetching. So this is great. In fact, a lot of companies do this, but it's still not as fast as it could be. And as you grow, you're going to need more speed. How do we get more speed in this architecture? Caching. Okay, so you need, this is reading from disk and writing to disk. Disk is slower than random access memory or RAM. So you'll need a way to store some stuff in memory And then when a request wants it, you check there first. So you'll have some type of cache, like let's say in-memory cache. Redis is a common use case for this. And so then your app will read from either the cache that has it in memory first. If not, it'll go to the database and then store it in the cache and so on. Awesome. This is what most websites and apps look like, backend-wise. But even then, as your data volume grows, you're going to be like, okay, I have way too much data now, and people need to find stuff. Go on any app with a ton of data, Instagram, Reddit, TikTok. What's common? Search. So you're going to need a search engine here, and then you go like, okay, how do we do this? Should it be distributed? Is it Algolia? What's Elasticsearch? Kibana? I heard this word. Does it mean the same thing? And so you have, okay, and so now your API needs to talk to that too, but then your database needs to find some way to like store itself in the search engine as well. You'd probably come up with some type of queue, right? And so, wow, look at this. Oh my goodness. So why am I drawing this? This is common for like many web applications at scale today. Like you could, like Uber, TikTok, whatever you want, there's some variation of this in large tech companies. The wheel keeps being reinvented. What I want to show you is while the backend has grown so much over time, the UI is just the UI. It's at some point, your UI will need a better data fetching story to keep up with this. And React Query has an awesome cache. There's a lot of libraries that do this for you. They use Suspense for data fetching under the hood sometimes. And it's this primitive in React that I'd like to talk about and understand together today. In fact, this isn't even indicative of a full backend because all of this is wrapped in something that lives in what's called an availability zone. Availability zones live in regions. Regions live in virtual private clouds. Backend is pretty complex. And yes, the UI is also very, very complex. What I want to talk about is literally just this portion. So if we select all of this stuff in a dashed line, what we're going to talk about today, because it's React Brussels, is here, right? Is just the UI layer, and how it can match similar complexity on the backend side using primitives like Suspense for data fetching. Does that sound good? Are we on board? Awesome. See yes, one person gets it. Excellent. Thank you. So I want to talk to you about 3 ways to fetch data in React. 3 ways to fetch data in React. How many of you are familiar with 2 ways to fetch data? Client-side rendering, server-side. You may have heard these terms. I'm not talking about that today. Shande, she's talking about that. I'll come to her talk. I can recommend. Fantastic speaker. I am talking about 3 ways to fetch data in React that is relatively known and common. These 3 ways are, 1, you render your components, then you fetch. This is probably the most common way people work with data in React today, where you have a component. In your component, you have some type of state, and when the component renders, so in your render method, or in your function body, use effect, fetch, then set state. Client side. This is quite common. You literally render your component. When your component renders, then you fetch data, and then you set state. Number 2, this has been flipped on its head in some environments for performance gains. Can you understand why this would give you a performance gain? It's because you start fetching early. If you start fetching early, you get a response early. And then you render later, which is fast anyway. So another strategy is to fetch super early. This is outside the scope of your component in what is called module scope. So as soon as you import your file, you're already fetching. And then when the promise resolves later in your component, you set state. Number 3, this is the premier, the way with React 18 and concurrent features to work with data in React. You render as you fetch. See, React has this amazing mechanism of concurrent features where it can render your stuff and then pause and be like, whoa, I need data, bail out, flush that to the screen, fetch data, come back, continue rendering, and then flush that to the screen. React is now pausable with concurrent features, and that's where Suspense for data fetching fits in. I've been talking way too much. I see some of you are just like, dude, what are you saying? I'm with you. There's a voice in my head going like, dude, what are you saying? So with that, let's just code, Let's just write some code. But before we code, I have a disclaimer. Listen, we're about to write code that maybe a lot of people think is like, whoa, can he write that? He can because he's on stage. But This is not production code. This is let's learn together, education, conference, fun, vibe, let's hack. It's hackathon code. It's not production code. Do not use this in production. The documentation is great. Use the docs for production. In fact, let me show you.
Is this not flagged as experimental still?
No, these are not experimental. In fact, I'm glad you brought that up. So Suspense and data frame, this is a React docs. By the way, don't believe anything I say. This is maintained by like actual people who work on React, so like trust them. In React 18, you can start using Suspense for data fetching in opinionated frameworks like Relay, Next.js, Hydrogen, or Remix. But here's the kicker. Ad hoc data fetching with Suspense is technically possible, but still not recommended, right? And I see this and I'm like, wait. Why? What is it? So it's possible. Therefore, curiosity, engineer, let's go. So not recommended in your production use cases, but how do we do this? How do we build something that uses this low-level primitive for fun and learning? Okay, so instead of let's code, let's just hack some stuff and see where we go. That is the last slide, and now we get to just like play. Welcome to the playground. I have 20 minutes. It would really help if the internet can work, though. You know, that's it's pretty. If you're on Wi-Fi, stay on Wi-Fi. I'll just use my hotspot or something. Or Hugo, can I use your hotspot? How do we? Does this work? Let me see. Can you like applaud or something so I'm not? Easiest way to diffuse the tension. All right, let me see if I can connect to my hotspot here. I knew I was taking a risk on the public Wi-Fi, and you know what? I said, it's fine. It's gonna, well, I guess it is fine. Is it fine? Okay, it's fine. Cool. So anyway, thank you. All right, so what we're gonna do is we're gonna build something with Suspense for data fetching to learn what libraries do under the hood and why we shouldn't, okay? So what we have here, I will start this. I will do yarn parcel source index.html. Boom. It's going to start a dev server, and I'm going to get the jokes. There's an amazing individual in the React community. Her name is Shruti Kapoor. Shout out, recommend following her on the Twitter. Just fantastic engineer, speaker, whatever. She has a GitHub repo of developer jokes. Just jokes, you know. So what I want to do is fetch jokes from an API with Suspense for data fetching, build a UI with it, and kind of talk through how it works. We'll walk through the 3 strategies. Render, then fetch, fetch, then render, and lastly, we'll look at render as you fetch to get a holistic picture. All right? Let's go. So let's walk through the code of this thing. Let's open the editor, and we'll run our dev server again. All right, so now what do we have here? Let's look straight at the entry point. We have the entry point of any React app. This is a bit different from what was in previous versions of React. You actually create a root like this, and then you render your app into the root. If you use Next.js, you'll probably never see this. If you use Remix, you'll probably never see this. This is what's happening in frameworks. So the next question, logically, is what is app? So if we go into app, so app's a component that renders UI. So we have, let's hide this thing. So we have here UI. We have a main, h1 the joke, so you kind of see that here. We have input, you kind of see that here. If you can follow my cursor, that is. And we have a paragraph. These are amazing developer, that's here. We have a jokes component, which you don't see. And we have copyright no one, because it's open source, right? What is this jokes component that we don't see? This is probably the thing that's going to render jokes, okay? So here, we have jokes, set jokes, which is an empty array. Well, that's probably why we don't have any jokes. So step 1, render, then fetch. Let us fetch jokes from an API. I store the jokes in a database on Zeta, because I work there, and that's the easiest thing for me. There's a database called dev jokes, and like literally all the jokes are here. It's just a long, really long collection of jokes. So I'm going to query this in my React app. I will get a code snippet, give myself an authorization key here, and I'm just going to copy that into my React app. And what I'll do is, just your standard use effect. David has a great talk, by the way, today on use effect. You should go to that because he'll tell you not to use it. He's right. And what I want to, wow, okay, there's another joke API. Anyway, I will fetch this, and instead of console logging the response, I will set jokes to response.data. or .records actually, and save this. And now I think we should have some jokes. Okay, so we have some jokes. Question, what is the most used language in programming? Profanity. This looks good. We have jokes, and we are now rendering the component, then fetching. That's what's happening. This is maybe a little bit too fast. So let's throttle this thing. Let's do throttle. And let's slow it down. Let's slow it down considerably by like 1.2 seconds, just to make ourselves feel the pain. So now if I reload this, yuck, there's a flash. Do you see that? Ugh, it's still a bit fast, but I don't like that. We can maybe fix that. Okay. As a performance optimization, maybe we fetch early. Maybe we fetch, then render. Would that help us avoid this flash? Would that give us good vibes with a React app? Let's try. So we go over here, and we fetch, then render. How do we do that? We take the fetch call just until we set state. Let's not throttle it. Okay. And we'll say like promise. And we'll store the promise here in module scope. I don't need this anymore. So before the component even is defined, we'll be like, listen, promise is fetch this thing. Okay, options is undefined, so I'm going to copy this up here as well. Okay, good. So now we're fetching like in module scope, and then in the component, we're like, whenever that thing resolves, set state, right? This should be faster, and some would say it is. We still have the flash though, but some would call this an optimization. And in many environments it is, especially depending on the complexity of your data. This is fetch then render. If you want to look at the code, we're fetching early in module scope, somewhere here. And then the problem with this though is because you're in module scope, if this is running on a server, and if multiple people access the same module, then they'll see each other's you can leak data between loads here. So it's not safe. Again, probably why offload this to a library like Next.js or Remix or something else, okay? But this is how you fetch, then render. But we're here to talk about like suspense for data fetching. The React 18 way that the libraries are using, but you probably shouldn't. But I feel like it's important to learn how the libraries do it, right? So let's look at how the libraries do it. What we need, a primitive of suspense for data fetching is called a resource. Conventionally, it's not like defined hardcore, but it's just a convention. And what you want to do is you want to read from a resource. React knows how to work with these resources. A resource is something that exposes a read method, and then it just gives data to React in a very opinionated way. Let's look at those opinions. So what I'll do is I'll keep all the code there in module scope. Let's maybe make this a little bit bigger. And so what we'll do is we'll say const create resource. I want to create a resource that React knows how to use. Create resource takes as an argument, something that returns a promise, and it's literally the type is something that returns a promise. And now, yeah, Copilot, awesome. Copilot is just going to write my talk for me. Let's let Copilot do this and then talk about what's happening. So we have two state variables. Status of like what is happening in this resource. Are we fetching? Are we successful? Are we failed? And the result. What is the result? It's undefined by default. There's something, Copilot calls it a suspender. I don't call it a suspender, but anyway. What we do is we call the thing that returns a promise, and when the promise resolves, we set the status to success, and we just store the result here. That's all, okay? If it's an error, same thing. We set the status to error, we store the result here. By default, the status is pending. So far, so good? We're just fetching and then setting state variables, nothing fancy. What does this return? It returns an object with a read method. And when you read from it, if the status is still pending, meaning if the promise has not yet resolved, if the data is not available, you literally like throw the promise. Just throw it somewhere. Good luck. React 18 knows how to catch this thing. That's the magic. So React has something similar to a try-catch somewhere in its layers that will see, oh, I caught a promise. What do I do with it? And so when it catches a promise, it will be like, okay, I see what you're doing. Flush something to the DOM, wait for that to resolve, and then render again. It can pause when it catches a promise. That's the magic, okay? So we throw the suspender. If the status is an error, we throw the actual result of the response. And if it's successful, of course, we just return the result. This is what a resource does. This is what the libraries use under the hood. This is called a suspender. So we have this thing now. Let's see if we can use it. So what we'll do is we'll say const joke resource. Actually, let's do create joke resource. Let's make a factory. Create joke resource. It's a function that calls create resource with our fetcher thingy that was just above this thing here. So I want to return it. The first argument is thing that returns a promise, right? So we'll have this be something that returns a promise. So a function that returns a promise. Instead of const promise, we'll just return this thing. And instead of just sending JSON, we'll send response.records just for posterity. This looks good. So now we have a joke resource. What we'll do is we'll create it in module scope, initial resource, and we'll call create joke resource, just like that. So far, so good. Now, how does our React code change? We don't need state anymore. We don't need use effect anymore. David Stock is called goodbye use effect. Good. Let's get rid of all of this. And instead, we'll just read from our joke resource. Initial resource dot read, just like that. So no state, no effects. We're just reading from something defined in module scope. Does it work? It does. So it may not look as impressive, but what's happening is we're rendering as we fetch. So like the component's rendering, it reaches this joke, this hole here, this where the question is, and it pauses, and then very fast, we'll get the data and reload. And you'll notice there's no flash of anything. There's a reason there's no flash of anything, and that is because Suspense for data fetching is awesome. TLDR. Here's why. With Suspense for data fetching, because it works like a try-catch, you can actually catch that promise anywhere in your DOM tree, in your JSX tree, and choose when do I show stuff, when do I hide stuff, and what to hide while data is loading. It's pretty cool. So let me show you that. So you can say, I want everything. So I want all of the stuff to show at once, which is I'll just hide everything behind the suspense component like this. And now, while data is loading, I get nothing, but when data is available, I get everything. Okay? If I move this and say, you know what, the heading can show, but nothing else while data is loading. So now you see this flash, even though the heading is still there. Let's throttle this to make it a bit more obvious what's happening. So instead of returning fetch, we'll return throttle, and we'll throttle the fetch by, again, 1.2 seconds. I figured that's the number just enough to annoy us. So now, you see this? It's kind of annoying, but it's kind of cool that I can selectively choose what if is it good UX, would you say, to show the search field even though there's nothing to search? If someone said that, I can do that by just hiding or not wrapping the search field in suspense. And if I do that, you see that? I can selectively choose what do I hide or what do I show. And I can even choose to show this paragraph and really just leave a hole where the jokes should be. Suspense for data fetching allows this because React will catch the promise and then decide like what to show and what not to show. Okay? This is pretty cool. It gives us a lot of potential to build UIs that are always available and ready. One problem with this, though, is search doesn't work. I can't like type something. So let's fix that. Let's actually make search work. How we can do that? We'll have to have use state again because search is stateful. But we can store this joke resource in state, right? So create joke resource, the initial resource. We just recreate it every time we want to search. To do that, we'll have it accept an argument, string, and we'll add some filters to our request here. So we'll just say, filter joke contains, this is Zeta, by the way, contains search. Okay? But we'll only do this if search actually exists. So we'll say if search, then do that. Otherwise, don't include the filter if there's no search. I mean, that's pretty logical, if you ask me. Okay, so now what I'll do is I'll keep some state. So I'll say const joke resource, set joke resource. You see where I'm going with this. And we'll use state is the initial resource. Okay? And then we'll read from this thing. And then our friend use effect, when the search changes, then we'll just recreate the joke resource every time. So when the search changes, exactly, Copilot, awesome. This makes sense? So we just make a new resource every time the search changes, and then read from that. Does it work? It kind of does. Let's search for the word wife. There's a joke about it. Okay, I mean, it works, but every time I enter a keystroke, it's kind of annoying. It destroys the search field because it's loading. Married life of a developer, wife, right, 100%. But like, it's throwing away my thing. Look. This is horrible UX. Can you imagine you type one character and like stuff disappear? Suspense to the rescue. So what we can do is go back to, oops, I should not have closed that. Go back to our tree and instead put it here, under the input. We put the suspense, it's called a suspense boundary. Put it under the thing. So now I can type as much as I want, wife. Oh dear. Profan. See, it kind of works, but I don't like this flashy, at least the search doesn't disappear. That's one thing. But that's pretty nasty. How can we fix this? In fact, how can we tell React, listen, this resource swapping and data fetching thing, it's a low priority update. What's higher priority is to keep stuff on the screen. React, can you do that for me? Concurrent features say yes, it can. You can like signal to React, listen, these updates are higher priority, do them. These are lower priority, do them maybe later. So for example, the keystroke in this example, like let's go back and destroy the UI completely. So let's save this, right? And oh man, so like what? So the text input is a high priority update. I type something, I want to see it on the screen. You with me? Like it's important. I don't want to wait like 1.2 seconds to see my stuff. So we need to tell React, listen, prioritize the input, deprioritize swapping the resource and doing the search. We do that using a new hook, React 18 called use transition. Start transition it returns a tuple with the second item in the tuple is start transition, and the first one is transitioning. And so here, what we do is, I'm in the wrong component, awesome. Pretend that didn't happen, let's go here. And, right, so we'll import use transition automatically, thank you TypeScript. And so now, where I set the joke resource, I say start a transition to do this whenever you want, React, but don't take away my text input. Okay, that's what's happening. I speak to machines with code. All right, so now we don't actually need is transitioning. You would use this for some type of selective UI stuff. Let's just, and now this signals to React, listen, changing the resource is lower priority. So now I can very comfortably type. It doesn't go away, but it does, like later when it's available, it does at some point do that. Right? So the search field is not going away. My UI is so much nicer. Wow, thank you, Suspense, for data fetching. It can get even better. So if we remove God, that's really slow. Okay, if we remove the throttling, then we're talking production level, which, by the way, don't use this in production. It's just for education. But let's do that. What? I think, nope, something's wrong. Oh, yeah, let's do that. Okay, so now I've removed the throttle, right? So like this, ooh, you see that? Wow, profession, capital P. Look at that, and so this UI is so interactive, and it's doing a request on every keystroke, but it doesn't feel like it. It feels like fluid. Wow, look at that. So that's the magic of Suspense for data fetching. And that is what's available to you in React 18, preferably through libraries, but also kind of on your own. That was a fun hacking session, no? Thank you. So that is, we looked at, let's talk about what we've learned. We looked at render, then fetch, which is kind of the current predominant way. We looked at fetch in module scope, then render, which is used by some libraries with careful handling of the edge cases because servers and modules are stateful. And we looked at the Premier React 18 render as you fetch. That is actually available to you today. I think in React Query, SWR, some libraries that allow you to fetch data will do exactly that under the hood. Now you know. In fact, if you feel so empowered to go home and create your own data fetching library and contribute to the open source ecosystem, power to you, but that's what's happening under the hood. Let's wrap up with how do we actually use this stuff? How do we use this stuff in our... Do I expect you to like go home and like write all this in production? No. Is this even useful? Kind of. It's useful to know what's happening under the hood. Like worldwide, millions of developers use React daily. but fewer understand React. Like, why is it the way it is? What's happening? And there is the value, I think, in this talk. I think there's a lot of curiosity that could be awakened, that could be explored about what's happening under the hood, which when we understand things about what's happening under the hood and why I should use a library instead of my own thing, we are able to be more fluent in the language, right, and write these applications. So how do we use this? We think about it passively. Okay, when I do this, this is happening. That will enable us to write more fluent apps. With that, hey, React Brussels, I want to say thank you so much for having me be a part of this conference. Appreciate you.